Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and this is Spectroscopy for Chemistry in lecture number 25 for UV spectra. In this lecture I will explain you the factor affecting the value of epsilon, and the first factor is type of transition. So first of all, again I will have to explain you about transition for UV spectra. So this is kind of reminding you a process of transfer of electron from ground state to excited state is known as electronic transition. In molecule, electronic transition occur among molecular orbitals like BMO, ABMO, and orbitals, etc. There are two types of transitions. The first one is called allowed transitions. Or smooth transition. The electronic transition which occurred smoothly and follow selection rule is known as allowed transitions. The probability of allowed transition by molecule is maximum. Allowed transitions are sigma to sigma star or pi to pi star. So when electron transit from sigma to sigma star or pi to pi star orbitals, it is known as allowed transitions. Okay. Next one is known as forbidden transitions or difficult transition. The electronic transition which occur with difficulty and do not follow selection rule is known as forbidden transition. As for example, N to sigma star transition, N to pi star transitions. These kind of transitions are forbidden. Forbidden transitions occur with difficulty. Now, to understand or to know whether the electronic transition is allowed or forbidden, we should know selection rule for them. So in UV visible spectra, the type of transitions depend on selection rule. Okay, that is very, very important. So selection rules are many, but for electronic transitions we will study few selection rules. Now, selection rules for electronic transition. Particularly for UV visible spectra. This is very important. There are many selection rules for different things, but now we are focusing only selection rules used for UV visible spectra. There are three main selection rules for that. The first one is spin quantum number rule. And that is delta S should be 0. So when electron is transferred from BMO orbital to ABMO orbital, the value of spin quantum number of an excited electron should remain the same for allowed transitions. That means electron's spin rotation should remain the same. Let us take example, then you can understand this easily. There are two orbitals. One is BMO, another is ABMO. And there are two electrons in BMO orbitals. You know that both have opposite spin. Total spin say S1, and here total spin of ABMO orbital is S2. Okay. During excitation, when electron absorb ultraviolet visible radiations, one of these electron absorb energy and transit to higher level, that is ABMO. Suppose this electron is transferred to ABMO, and if its spin rotation remain the same anticlockwise, here S1 and S2, then you can see that when during excitation, this total spin delta S, which is S2 minus S1, that is minus half minus minus half, will be 0. So there is no change in the spin rotation of this excited electron. This is excited electron and its spin remain the same. Okay, so here total spin delta S should be 0 for allowed transitions. Okay, so this is the condition. The electronic transition in which delta S is equal to 0, it is known as allowed transitions. Its transition probability would be high. And so that the value of epsilon would be high, also high. And if delta S is not equal to 0, that means if electron transfer to ABMO with change in spin rotation, then it is called forbidden transition. Okay, so this is one of the selection rules which I have discussed here, and I think time is enough for this lecture. In next lecture, I will explain you two more selection rules for allowed transitions. Thank you so much.